Fundamental Resonance, Episode 4. Internal Medicine, Anechoic Chambers, and Medical Sonification. Imagine stepping into a room where sound, as you normally know it, does not exist. A space where clapping your hands results in a muffled thud instead of a slap. Where a scream seems to die as it leaves your mouth, and you can see the lips of the person across the room from you moving, yet they don't seem to be making a sound. A room where you may even be able to hear yourself blink. These are just some of the things you could experience within an anechoic chamber. Many people think that an anechoic chamber is a place of silence. That is not entirely accurate. While it is certainly quiet in an anechoic chamber, anechoic does not mean silent, but rather free from echoes. All surfaces within an anechoic chamber, even the floor, are lined with sound-absorbing materials, such as foam wedges or baffles. This creates an environment where sound waves are absorbed to such an extent that there are no echoes. Sound leaves its source but doesn't bounce back, its energy dissolved by the dense, soft, uneven surfaces that line the chamber. Because of this, there is no ambient sound. The walls of an anechoic chamber are the sonic equivalent of a black hole. There is no reflection of sound off the walls of an anechoic chamber. And because of that, everything sounds very different. This lack of background noises, this auditory void, is said to be disconcerting, a surreal and disorienting sensation. And not just in a liminal way, but in a literal one. We may not use echolocation to navigate our environments like bats or dolphins do, but a few minutes in an anechoic chamber where there is no ambient sound is enough to realize that humans do in fact rely on sound stimuli for spatial orientation. Some people who visit the anechoic chamber even report dizziness or feelings of vertigo. What our brains register as a disquieting silence is simply a profound lack of response from our environment. And after a while of sitting in this unresponsive space, notice I did not say silent, our brains begin to recalibrate. Our brains are wired to seek patterns and stimuli consistent with previous experiences. In the absence of external sounds, the brain seeks to amplify whatever sounds there are because it is used to receiving input where now there is none. In the face of apparent silence, quantifiable, measurable, palpable silence, the brain turns its focus from the external soundtrack to the internal one. It raises the levels and ups the gain, and what becomes audible are the sounds of the body, the heartbeat, the flow of blood, the hum of the nervous system. Our bodies are constantly producing sounds and vibrations. They are often just too subtle for us to perceive. Silence, as perceived by the human ear, is never truly absolute. Of course, there is no way to record the sounds of one's body that become audible during time in the anechoic chamber. I have created an approximation of my own experience listening to the body in the anechoic chamber using synthesizers. Those are the sounds that have been accompanying this episode of Fundamental Resonance so far. There are other ways that we can listen to the sounds of our body, however. Listening to the body, or auscultation, has been a diagnostic tool for centuries. Through medical technology, our heartbeat, our breathing, and even our brainwaves can be monitored. Using devices such as EEG, EKG, and ultrasounds, as well as digital stethoscopes, data can be gathered about usually inaudible noises that accompany our physiological processes. And through sonification, the process of turning data into sound, the rhythm of these normally obscure processes can be heard. This audio collage represents the sounds of our body, revealed through our own experience as well as those elicited through diagnostic tools. The sounds of medical device sonification that accompany this episode were collected from the following sources: the MIT BIH Arrhythmia Database, which is available in full at physionet.org, the research resource for complex physiologic signals. The Respiratory Sound Database, published as part of the 2017 International Conference on Biomedical Health Informatics. Kaswara, a respiratory sounds dataset for remote screening of SARS-CoV-2 infection, created by the Indian Institute of Science, Bangalore, and the UC Irvine Machine Learning Repository. Fundamental Resonance is a production of Fulcrum Arts. Composed, written, narrated, and edited by Sam Rowell. Audio mastering provided by Sean McCann.